The title of this note is Graphing Tangent and Cotangent. And your outcome is that you'll be able to graph any transformation of tangent and cotangent. It's going to feel very similar to sine and cosine with one notable difference. So here is the parent function of y equals tangent x. Looks kind of like secant and cosecant with those vertical asymptotes, but instead of parabolas, we have these mini cubic functions in between each set of asymptotes. But notice that it repeats every pi. So this p here should be pi. I'm crossing that out. So there's an x-intercept at every interval of pi. So 0 pi, 1 pi, 2 pi, negative 1 pi, negative 2 pi, so on and so on. And then there's vertical asymptotes at what we say odd multiples of pi over 2. So that's like 1 pi over 3 pi over 2, 5 pi over 2, any odd number. So the period of this function, it repeats every pi instead of every 2 pi. And that is the key difference between the sine and cosine graphs and the tangent and cotangent graphs. So take a look at these steps. They ought to look familiar. So you're going to identify A, B, and C and the amplitude. The period, instead of 2 pi over b, will just be pi over b, because the period of the parent function is 1 pi. You're still going to identify your counting interval as your period over 4. Now your left and your right endpoints, again, it's going to change. The left endpoint is still setting the argument bx minus c equal to 0. But for the right endpoint, you'll set it equal to pi, because again, the period is only 1 pi. And then once you have that, you'll make your table, just like we've been doing. So let's take a look at this example together. We're going to start it, much like the others, identifying A, B, C, and D. A is the coefficient, so it's 3. Don't get tricked and think that it's 1. B is the coefficient of your input variable. C is the opposite of the number inside the argument. And D is the value being added, so it's 1. Sometimes that's behind the function, sometimes it's in front. Okay, so our amplitude is still 3. Amplitude is not really the right word here. There isn't a word for the tangent or cotangent function. So to find the period, it's now 1 pi over b. So pi over 2. Our counting interval is still going to be the period over 4. So dividing by 4 is the same thing as multiplying by 1/4. So my counting interval will be pi over 8. Now to find my left endpoint, I'm going to take the argument and set it equal to 0. So first thing I'm going to do is I'm going to subtract pi over 2 from each side. And then my last step will be to divide by 2. Same thing, dividing by 2 is the same thing as multiplying by 1/2. Times 1/2 times 1/2. So I get that theta equals negative pi over 4. Now the right endpoint, still set the argument, instead of equaling it to 2 pi, equaling it to 1 pi, because that's the period of the parent function. So 2 theta, that's a 2, plus 2 pi now equals 1 single pi. So I'm going to subtract pi over 2 from both sides. Remember, again, if I want to subtract, I really need these fractions to have the same coefficient. So it's like 2 pi over 2 minus 1 pi over 2. So just 1 pi over 2. And then same thing, multiply by 1/2. And I get that theta for the right endpoint will be positive pi over 4. So now we can make that table. So our left endpoint will be negative pi over 4, giving ourselves 3 spaces. And then the right endpoint will be positive pi over 4. And then our counting interval, we said, was pi over 8. So I want to add 1/8 each time. It'd be a lot easier if that denominator was 8. So I'm going to think of that as negative 2/8. I'm just multiplying by a fancy form of 1, 2 over 2, so my denominator is 8. So I'm going to add negative 2/8. I'm going to add 1/8 to that, and I get negative 1/8. And then adding an 1/8 again, I get 0. Adding an 1/8 again, I get 1/8. Adding an 1/8 again, I get 2/8, which simplifies to 1/4. So now we have to fill in our values using the tangent function. So here's where we want to think about the unit circle. I'm going to sketch a little unit circle for myself. And this value here is 1, 0, 0, 1, negative 1, 0, and so on and so on. Tangent is y over x. So the tangent for this first angle for 0 degrees is 0 over 1, or 0. The reason the period is only 1 pi is because the tangent function, the y over x, will repeat in the top and the bottom half. So only doing the top half of the circle. So by cutting our counting interval, by taking our period divided by 4, our counting interval is fourths. So those are our 5 spaces. So this one right here, this is exactly halfway between 0 and 90 degrees or 45 degrees. You'll remember from your unit circle that the ordered pair there is radical 2 over 2, radical 2 over 2. You take the y variable, divide it by the x variable. Since they're the same, y divided by x would be 1. Now when you get up here, y divided by x is 1 over 0. That's undefined. That's where you're going to have that asymptote. The next one will be right here. I'm just jotting down the values of the unit circle. Y divided by x will be negative 1. And then the last one, 0 divided by negative 1, will be 0. So that's the tangent of your bx minus c. Now, just like we've done every other graph, now we're going to consider a and d. So our a value was 3 and our d value was positive 1. So let's check that. 3 and positive 1. So I'm going to take each value and multiply it by 3 and then add 1. I'm going to skip that one because it's not actually a number. So now I'm ready to put my true y values. So 3 times 0 plus 1, negative 3 plus 1. And this is still undefined. That's the location of the vertical asymptote. So now I'm ready to sketch my graph. So when x is 0, there's my first vertical asymptote. And according to my table, at negative pi over 4, the output is 1. And then at negative pi over 8, which is halfway between negative 1/4 and 0, my output is 4. So I'm going halfway right there, and I'm going up to 4. And then on the other side of the asymptote, at 1/8, I just got to scroll down so I can see this. I have negative 2, and then at 1/4, I have 1. So that's up at negative 2, and then back up at 1. So what's happening is each of these dots represents half of that cubic function. So that's going up like that. The period, remember the period is pi over 2. So if my first asymptote is at 0, I can add pi over 2. That's now my next asymptote. Add another half pi. I can see on this graph that a half pi is 2 lines on the grid paper. So just every 2 lines I'm going to put an asymptote. And so if that's negative 2 and that's 4, then halfway between there will be at, That's at -2 and that's at 1. The next one will be at 4. So you can sort of extend your pattern. So the next one will be same pattern. There, there, and there. It's a cubic function, so it's like concave up there and concave down there. You know, this board's a little funky, so we're doing our best to follow along. Concave up and concave down. That blip is just a weird blip in the calibration. So the amplitude being hold on. Okay, so I got this graph. The amplitude being 3. Amplitude is not really the right word for it. I'm not sure if there's a better word for it, but it's still the distance between the midline, and it's not really the high point. But notice that that has a vertical distance of 3. It's really the stretch. This graph has been stretched out from its parent 3 times. So there's a graph of tangent. Let's look at a graph of cotangent. So here's the parent function. It's the reciprocal of tangent. So the x-intercepts and the asymptotes have switched places, and the cubic, instead of increasing left to right, is decreasing left to right. So your x-intercepts, which were at pi, those are now your vertical asymptotes. And then your vertical asymptotes used to be at your odd multiples of pi over 2. Now those are your x-intercepts. All the steps are still the same. So let's look at an example. So here we have A is 4, B is 1/2, C is negative pi over 4, and D is -1. So our period will be pi over B, because the parent function has a period of pi. So pi over 1/2, same thing as 2 pi. So the period of this is now 2 pi. And our counting interval is our period over 4. So we're going to count by pi over 2 to make our table. So our left endpoint, we take the argument, we set it equal to 0. This hasn't changed. So subtracting pi over 4 from both sides, and then multiplying both sides by 2. The right endpoint, only slightly different. Instead of being at 2 pi, like it is for sine, cosine, secant, tangent, it'll be at 1 pi for tangent and cotangent. I'm subtracting pi over 4 from 1 whole pi. 3 pi over 4, 1 whole minus 1/4 is 3/4. We should be getting faster and faster at these, more and more comfortable with these fractions. And then multiplying that by 2. Notice the 2 in the numerator, 4 in the denominator can be simplified to just a 2 in the denominator. So there are the left and the right endpoints. And now I'm ready to make a table. My x values. There's the first one, and I'm going to leave myself 3 blanks. And then the last one is my right endpoint, which is 3 pi over 2. And then my counting interval was pi over 2. So I'm adding pi over 2 each time. And now here, we're going to take care of the cotangent of the argument. So again, we want to think of our unit circle. We're only going from 0 radians to pi radians. We're ignoring the bottom half of the circle. But we are still cutting it into fourths. So we're going to look at those places. So right here, tangent is y over x. Cotangent's the reciprocal, x over y. So 1 divided by 0, undefined. We're starting with an asymptote. The next spoke, radical 2 over 2, radical 2 over 2, x divided by y, they're the same. So it'll be 1. The next spoke, x divided by y. The next one, the x divided by y will be -1. And then the last one, x divided by y. Again, we have division by 0, undefined. We have another asymptote. So now we're going to continue on just like we've done for every single graph. We're going to consider A and D. So the A value, I'm going to go back up because I forgot. My A value is 4, my D value is -1. Okay, so we're doing 4 times the number minus 1. And remember, I'm skipping those asymptotes because they're not numbers. There's nothing I can do there. They're going to remain asymptotes, no matter what the stretch or shift up and down is. So I just sort of rearrange this so I can finish writing. So my final y values, this is going to be my vertical asymptote. It's undefined. 4 minus 1, 0 minus 1, -4 minus 1, and then another vertical asymptote. So lastly, I'm finally ready to graph this thing. So at -π/2, I would have a vertical asymptote. Notice that that would be 2 tick marks. I've got one here, so I kind of need to go off just by one more to put my vertical asymptote. And then at 0, I'm at 3. And then at π/2, I'm at -1, and at pi, I'm at -5. So amplitude is really just the vertical distance between those points. Notice it's 4. And then at 3π/2, my right endpoint, there's my next asymptote. So this is one complete period. Those 3 points, make sure you do a cubic function. So it's concave up, and then it switches to be curved down, concave down. And then I could repeat it. I'm seeing that pattern. So if my next asymptote would be 2 pi away, so I have, this would be 1 pi, right? 3π/2, 5π/2, the next one would be 7π/2, which would be right here. Here would be my next asymptote. And I can follow the pattern. At 2 pi, I'd be at the high point. At 5π/2, I'd be at the midpoint, which is here. And then at 3 pi, we'd be at the low point. So there's the second period of that cotangent function. So that's it for these notes. We're going to practice this in class.